In this video, we're going to have a look at the proof of the right-angled triangles theorem. This theorem says that the perpendicular drawn from the right-angle vertex of a right-angled triangle, that's the straight line drawn from the corner, that's part of the right angle, straight down, perpendicular to the opposite side. That line divides the triangle into two triangles that are similar to each other and to the original triangle. So let's have a look at what we're given. We're given that AD is perpendicular to BC, which means we've got that perpendicular line, and we're given that AB is perpendicular to AC. That means that our big triangle is in fact a right-angled triangle. We're then required to prove that triangle ABD, that's the small inside triangle on the left, is similar to triangle CAD, which is the small inside triangle on the right, which are both then similar to triangle CBA, which is your big outer triangle. So let's have a look at our proof. Alright, so we're going to start off our proof by proving some angles that are equal. Now remember, we want to break our proof up into chunks so that you can apply it to a triangle that looks different or a triangle that's named differently. So let's see what our first chunk is. Now we know that angle A1 plus angle A2 is equal to 90 degrees. We were given that. We were given that by virtue of the fact that AB is perpendicular to AC. Okay, you can then see that angle A1 plus angle B is equal to 90 degrees because we know that D1 is 90. We were given that by virtue of the fact that AD is perpendicular to BC. So if D1 is 90, then A1 and B must add up to 90 because of the interior angles of a triangle. And markers often like it if you do name the triangle, especially when there's more than one triangle. So let's actually add that in here. Interior angles of triangle ABD. ABD. Now you can look at the triangle on the right and make the same conclusion or a similar conclusion. That angle C, the whole triangle, that angle C plus angle B is equal to 90 because we know that angle A is 90 degrees. So that would be interior angles of the whole triangle, which is triangle CBA. Now conclusions that we can make from that is the first thing is that A2 is equal to B. Now the reason why I know that is because in these first two statements I have A1 and A1 being exactly the same, which means I've got A1 plus something being 90 in both cases, then both of those somethings must be equal. So we know that angle A2 and angle B must be equal. So that's why they've been marked off in the same color here. A2 and angle B are equal. Now we can also make similar conclusions. Let me actually rub this out so we can make a new conclusion. We can make similar conclusions with the next two statements because we know that these guys are the same. So I've got A1 plus B is 90 and C plus B is 90. Therefore, conclusion that I can make is that in fact A1 and C must be equal. So that's why they've been marked off here in the same color. A1 is equal to angle C. Great. Okay. So we've established some angles to be equal. So that was our first chunk that we did. So let's maybe just write a note here. The first thing you do in a proof is you establish some equal angles. Establish equal angles. Cool. Now that we know those angles are equal, it's actually quite straightforward to prove similar triangles. So the first thing we're going to have a look at is the proof of the two triangles inside, those interior triangles. We want to prove that they are in fact similar. So we're working in triangle ABD and CAD. Those are my smaller inside triangles. Now we proved just above that angle A1 is equal to angle C. We proved that here. A1 is in fact equal to angle C. Great, we've proven that. Then we want to state that B is equal to A2, but hang on a second, that's where we get it from. We've proved it above. Third thing we can prove is that D1 is equal to D2, which is 90 degrees. We are given that, just have a look at the diagram again, we're given that by virtue of the fact that AD is parallel to BC. So it's by virtue of that. We know that D1 is equal to D2, which is 90 degrees. So we have in fact proven that our two triangles are similar. Don't forget your reason, so don't forget to put in that angle, 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 that those two triangles, those two inside triangles are similar. So again, we want to chunk it up so that we can repeat this proof with different triangles that look different or labeled differently. So what did we do here? We proved interior triangles are similar. Okay, so the last thing we've got left to prove is that one of the triangles inside is in fact similar to the big triangle on the outside. So that's on your next page. Go here. Okay, so now we're working in triangle ABD and CBA. I've chosen just the small triangle on the left. Now in those triangles we know that A1 is equal to angle C, which remember we proved that right at the beginning. We know that angle B is common to both of those triangles, and we know that D1 is equal to angle A, which is equal to 90 degrees. That's by virtue of the fact that it's a right angled triangle, and we know that D1 and D2 are both right angles. Again, we've got our three angles. We have now proven that our triangles are similar. Don't forget your reason, angle, angle, angle. So my final conclusion is that all three sets of triangles are in fact similar.